this last screencast, we're going to go through a bunch of problems. So if you already feel pretty comfortable with the ones from the book or the homeworks, then you don't have to run through this entire screencast, but I'm just going to do some binomial and Poisson problems. So let's take a look at this one. On average, your secretary makes 2 mistakes per page. Notice that per option. So I'm starting to think, okay, this might be a Poisson problem, and that 2 is the average, so that would be lambda. You've told her that she will be fired if she makes 3 or more mistakes per page. So this is a greater than problem, so that signals that I'm going to need the complement rule. So I'm going to have to do 1 minus a probability. So what is the probability that that will happen? So we want to know the probability of 3 or more, which means the complement is 2 or less, or 2 or fewer. So basically, and I know it's a Poisson, so I'm going to go to Excel, do equals, and I know it's 1 minus, so I can do the 1 minus here or just wait till I have the probability and then do 1 minus. The complement to 3 or more is 2 or less, so I'm going to put 2. Average was 2, and I want the cumulative. And I already did the 1 minus, so the chance of her being fired is 32%. Okay, so B. Another problem, Eldora Ski Patrol example. The Eldora Ski Patrol has calculated a mean accident rate of 5 per week. Notice the 5 per week, so that kind of tells me this might be a Poisson problem, and the mean is 5. The number of accidents is distributed according to a Poisson distribution. What is the probability that exactly 0, 1, 2, 3, or 4 accidents will occur in any given week? Now this is one where the way it's worded, you could actually plug in, x equals 0, x equals 1, x equals 2, or you can do 4 or less. The way it's worded, I would make it more clear on an exam, but the way it's worded here, it allows us to do it both ways. So let's take a look at that. If we wanted exactly equal to, then we just put false when it comes to the cumulative. So for 4, let's say exactly 4, and the average is 5, and we'd say false for exactly 4. It's going to be 17.55%. I had already made that cell format a percentage, so it automatically converted that. But let's say we wanted 4 or less, 4 or fewer accidents, because it said, 0, 1, 2, 3, or 4, so that could also mean 4 or fewer. So let's just do equals Poisson. The problem said it was a Poisson distribution, and I'm going to do 4, average is 5, and say true, and the cumulative gives me the less than 4. Okay, so 44% for that. Okay, you manage quality assurance for a local company making spyware detection software. The company averages 10 errors per code, so per 2,500 lines of code, but that's also the X of interest is 8 errors per 2,500 lines of code. So that's an indication I don't need that number 2,500 in the problem. And I have average is 10. I see that per errors per lines of code. So that's an indication this is a Poisson problem, and the average is 10. So the X of interest here is 8 errors per 2,500 lines of code. So X is 8, average is 10, and I don't want the cumulative here because I want exactly 8 errors. Probability of exactly 8 errors. So equals Poisson. Probability that there's 8 errors when the average is 10, and I say false here because I want to know the exact point probability, and it's 11.3% probability. Okay, most airline flights don't experience any mishandled bags, so the probability of a mishandled bag is pretty low. Some flights will have 1, a few have 2, very rarely will a flight lose 3 bags, and so on. So it's reasonable to assume that the average number of bags lost is 0.3 bags per flight. Notice that per option, per flight, and it's something discrete. So bags is a discrete thing, so that tells you it's in chapter 5, so either binomial or Poisson. And that the number of lost bags on a randomly selected flight follows a Poisson distribution. What is the probability that 2 or more bags are lost? So this means I'm going to need the complement rule, since it's a greater than problem, and I'm going to want 1 or less. Since what I want is going to include the 2, the complement of that will not include the 2. So I want 1 or fewer bags, And it's a Poisson distribution, as it says. So equals Poisson. I'm going to do 1.3 is the average and say true. But again, don't forget to do the 1 minus. You can either do the 1 minus here or wait until you've got the probability and just do 1 minus that. I'm going to do it that way this time. So equals 1 minus this, and I get about 3.7%. So A. Okay, so I've run through some problems. Here are some common phrases. Sometimes it can be confusing what type of problem it is. So if you see something like X or more, or at least 5, no less than 6, that's greater than or equal to problem. Things like X or fewer, or at most, or no more than, that's a less than or equal to problem. So that's there in the slides for your reference, as well as the Excel commands that we've gone through in this chapter. Okay, and now that we've kind of covered Poisson and binomial, let's see if we can kind of discern whether the problem is binomial or Poisson, and why would it be one of those? Like why, can I point out that it's a discrete variable? So you manage Bookend Cafe, a popular coffee shop, and have found that the average number of customers per 15-minute period during the lunch rush is 8. Notice it says customers per minute, or per 15-minute period. I'm not going to need that 15 minutes because later on it's, what I want is the 10 customers per 15 minutes. So since the 15 minutes is in both, I don't need that 15. But notice it is a discrete thing per unit of time. So customers is a discrete variable per unit of time. So this tells me it's a Poisson problem. That average is 8, and the X of interest, or the one that I'm interested in, is 10 customers per 15 minutes. Okay, so the X of interest is 10 and the average is 8. And I know it's a Poisson problem. So equals Poisson. I want to know the probability of 10 when the average is 8. And I want an exact point probability here, not a greater than or less than problem. So it's about 10%, 9.92%. Okay, what if I want to find the probability that there are 2 or fewer? So that's a less than problem. I don't have to worry about 1 minus when it's in a less than problem. So, and I do want to include the 2 because it's saying that there are 2 or fewer, not less than 2. Okay, so equals Poisson, 2, and the average is 8, and true. Okay, so the probability of 2 or fewer is 1.4%. Okay, and Best Buy, store manager for Best Buy, one of your greatest forms of revenue are the sales of service contracts. Your clerks have sold 20 in their last 100 customer transactions. In the next 12 transactions, what's the probability of? Okay, notice what type of problem this is. You're given a probability of success, basically. When it says your clerks have sold 20 in their last 100, notice that you have the setup there for a probability. And binomial problems have a probability of success, or pi. So you can do the 20 divided by 100 to get your probability of success, or pi. And the number of trials, or n, is 12. Okay, so the probability of no sales means my x is 0. So remember the binom dist function here. Probability of 0. Number of trials is 12. Probability of success, I can just put in 20 divided by 100 here, and it'll automatically calculate that. And I want an exact point probability of exactly 0. So I get 6.9% approximately. Okay, so exactly 2 sales. I'm going to do false for the cumulative again here, because I want exactly 2. And this time just plug in 2 for x. Okay, so the number of successes that I want is 2. Number of trials is 12. The probability of success is the 20 divided by 100. And I want to say false again here. Okay, so 28.34% probability of getting exactly 2. What about at most 2 sales? So at the most I want 2, that means 0, 1, and 2. So 2 is included and I want a less than problem, so I don't need to worry about the complement rule and 1 minus. So I just need true for cumulative and 2 for x. Okay, so equals binomial distribution, 2 successes, number of trials is 12, and the probability of success, and this time true. Okay, so 2 or fewer, going to be a little bit higher than exactly 2 because you're including probability of 0 and probability of 1, so 55.8%. How about at least 2 sales? So that means 2, 3, 4, 5, so it's a greater than problem. So you want 2 or more, which means the complement is 1 or fewer, or 1 or less. Okay, so I want to put in 1 and hit true, and then make sure to do 1 minus that. Okay, so equals 1 minus binomial distribution. 1, number of trials again is 12. Probability of success is 20 out of 100, and I'm going to say true. Just don't forget to do that 1 minus. So 72.5% chance of having at least 2 sales.